One. So, what is our last class? I think I took a project which is a
Yeah, fault detection.
fraud detection model, right? For by the way, if you want to build any data science application, or else if you want to build any kind of machine learning model, you already know that the data science life cycle, right? So first we need to go for understanding the business problem statement. Then, as for the business problem statement, we need to gather the data, or we need to collect the data. So by the way, the data, it was in a raw information. So with help of EDA techniques and feature engineering, then you might be extract the meaningful information to build the best fit model, right? So that's where we are now. I already explained that what could be various steps it could be involved in EDA. Okay, so I started giving some kind of practical information regarding on that particular EDA part. So let it be continue with that EDA concepts. Oh. Okay, let me open Jupyter Notebook.
Make it full screen, please, if it's not already.
I think it is in a full screen only.
Oh, okay.
Okay. EDA fraud detection, right? Hmm. What is the file? What is the file I created? Okay, EDA fraud detection only. Okay. Okay. Let me open the document. Hmm. So loading the data and checking the data types and variables, and look for the dimensions of the data. And understanding the data set, we went right. Let me go for the descriptive statistics. Okay. So make it markdown. It could be, and make it heading. Yep. So let me go for understanding that what exactly the descriptive statistics. Tell me, anyone, if you're already aware of some basic knowledge of statistics. Naveen, take an action and tell me what is the descriptive statistics. Hello, guys. Did you get my voice or not?
Yeah. So basically, it's calculating the mean and the median and all
Yeah.
those
Mm,
those
mm.
numbers, I guess, of any data
Yeah, so
set.
yes, that's correct. That's correct. So basically, data, it was in a different types, right? Okay. So data, it was in a different formations. So generally, we can call it as the data types, or else a data structure. Okay. So the data, it could be numerical thing. Like generally, we can call it as the quantitative. Okay. So second one is that generally we can call it as the qualitative. Okay, qualitative. So the data, it was distinguished with the two types. The first one is the quantitative, and the second one is the qualitative. Quantitative in the sense wherever the data, it was available in a numbers or continuous or else discrete type. Discrete means what? So something, it could be countable, right? That we can call it as the discrete. For example, so how many students are there in a class? There it could be like some finite number. There are 15 students are there in the class. Like, so what it could be, generally what we can say, something, it could be countable. Okay, how many objects are there? How many chairs are there? So something like this. Number, it could be a discrete number. Okay, so that we can call it as the discrete data. Okay, so continuous, what is mean that continuous? Continuous data means something, it could be a fractional data. For example, what could be your height? What you can say simply, it is not easily measurable. It's not easy to measurable. Okay, like 5.10, but is it exactly 5.10? No. So there could be some kind of variation is there. Okay, so it's a fraction and fraction of fraction. So in between two digits, there it could be infinite number of data, it could be there. Okay, so generally we can call it as the continuous data. So these two things are, it could be number actually. So whether the data, it could be discrete, or whether data, it could be continuous, generally we can call it as the quantitative. Okay, so and second type of data, it was a qualitative. Qualitative means the data, it was in a nominal or ordinal. Nominal. Nominal means names. For example, city names. Is there any order for city names? No, right? And names or else colors. Okay. Something, it could be object, yes, qualitative, like nominal. And the second type of qualitative data, it could be ordinal. What is ordinal? Some kind of order. Are you following my point? Something, it could be having some kind of order. Okay, for example, I have a data. I want to be fine. No, I want to make the data like medium height, or else medium tall, or else short. So I want to be distinguished. I want to I want to be distinguish the persons based on the heights. Okay, height could be very high, height could be medium, height could be low. There are some kind of order is there, right? High, low, or else medium. Okay, so low, it could be some kind of order or not. Okay, for example, I think everybody know about cricket, right? In a cricket, so people are categorized with some kind of order, right? Okay, players, instead of the player names, we can say that it's a player order. Okay, player number. So is it exactly number? No, it's an order. Yes or no? So in games, generally people will make it some kind of order, right? I need some kind of positive information from your end. You need to answer it, guys.
Yes, yes, yes. Understood.
Yeah, so when we are, when you guys know about like cricket, or you guys know about these things, right? So there it could be some kind of order. Okay, but it is not like, it's not exactly number. Number means something, it could, we can quantify. Like we can calculate the mean, we can calculate the median, we can calculate the so something like standard deviations. So many statistics we can do with help of numbers. But even some things, it could be numbers only, but it is not exactly numbers. So generally we can call it as the ordinal data. Got you? So what about Dhanlakshmi and Madhavi and Naveen and Nitin? Are you guys are following or not?
Yeah.
Yes,
Then
sir.
why you're not responding in the while I'm explaining? It's a basic things. I don't want to, I don't want to tell this all things. People already know this all things, but why? Why I'm telling this all things? You need to respond it. If I directly go for this thing, you might not understood. Okay. Yeah. In real time, in real world, the data, it could be categorized two ways. One is quantitative and second one is the qualitative. Okay. Quantitative means something, it could be measurable. Okay. So from that one, discrete and continuous are the type of the quantitative. So the examples for the discrete is number of players. When we take the game, okay, number of players. If I'm taking the scenario is the cricket, okay, in a cricket there are 11 people are there in the particular game, right? Okay, number of players in this particular game. Continuous means, okay, I want to find the weight of the each player. Okay, weight of each player. Okay, so that is the continuous type of quantitative data. Okay, and nominal in the sense names of the players. Okay, and ordinal type, the example for ordinal type in the same game. Okay, and every player, it could have some kind of order, right? So this person has to go first, this person has to go for second, this person has to go for third, right? Okay, there could be some kind of order. Okay, order of the play of each person, order number of each player. Okay, so that exactly the that is a way, you can make it the data into different things. Okay, let me take it some Excel sheet, or else I think you guys are understood. For example, for discrete number of players, there are 11 players are there. Okay, and here the 11 is the, for example, if I'm taking the game name is cricket, so there could be 11 players, right? And so for the 11 players, okay, I want to find the, I want to give that, height for, so every player has some kind of weight, right? So that weight we have to consider, for example, 78 point 45 kgs, something like that. Okay, name of the player, for example, Dhoni, or else, okay, or else Dhoni, Sachin, or Tendulkar, Kohli, something else, right? Okay, so ordinal in the sense, so each player, it could have some kind of order, right? So 7, 1, 2, 3, something like this, that we can call it as the ordinal type of data. Okay, so I hope you understood what exactly the data types, and how we can categorize those data types. So when I just want to show you Excel sheet. Now show you Excel sheet. Okay, so from that one, I want to show you that different type of datas. Okay, let me take it this credit card fraud train data. Convert. Okay, so time format. Okay, it's number, right? And yeah, see guys, this is ordinal merchant, right? Merchant is nothing but um merchant company names. So this is ordinal. Okay, sorry, not ordinal, nominal. Okay, and this category, even category also, it could be nominal. Okay, here amount is one kind of number, right? So but the number, it is in the continuous format or discrete format, tell me. Here the amount is continuous or discrete.
Discrete.
It's the continuous, not discrete. Discrete means something, it could be a number. Okay.
So but that's 110.43. That's a number, no?
Yeah, that's number only. That number, it could be have a two type of number: discrete number and continuous number. Discrete number means it could be of whole number, or else roundable number. For example, 110 is it's just a number. Okay. And
Right.
110.43 is a continuous number.
Okay.
110 is the discrete number. Okay.
Anjan, I missed that one. What is that discrete number? And
Yeah, it's just number, fractional numbers. We can call it as the continuous numbers. And so the whole numbers, we can call it as the discrete numbers. Something it could be
okay.
count. For example, in a class, there are 15 students are there. Okay. So you can go for everywhere. So the number, it could be like, it could be number, right? It could be some whole number, right? Okay. So when you are talking about some group of people, so there is no 15.5, right? So there is no
Got it.
15.2, right? Okay. So that kind of category, that kind of type of data, when we have it, then continuous data, or else discrete data. Discrete data in the sense, something it could be whole number. Okay. So here it is fractional numbers. So fractional numbers we can call it as the continuous numbers. And for example, zip code. So here the zip code, right? When you see this particular zip code, is there any kind of zip code something like 15.56? Actually, this zip code is also not the number. Actually, it's a ordinal type of data. Okay. Yeah. So fine. So this is the way when we have a data set, the data set, it could be contains the continuous data, discrete data, ordinal data, nominal data. So nominal and ordinal, it could be a categorical data or object type of data. Okay. So here street name, city name, state name, gender, and the first name, last name, category, merchant, these are all categorical type. So this categorical type, again, nominal and ordinal. Ordinal means it could be some kind of order. Okay. And nominal means there is no order actually. Okay. So just names. Just names. Okay. Yep. So when we have this kind of data, so descriptive statistics means, so ultimately you have to go for do some kind of statistics on the data, right? So if your numbers, if your data is numbers, then we can calculating that central tendency. We can calculate the central tendencies with help of mean, median, mode. So when the data, it could be quantitative data. So this kind of measures we can do that, like central tendency we can calculate it with help of mean, median, mode. Okay. And we can calculating the range and variance and standard deviations, quartile and interquartile range. These are all we can calculate it with help of the descriptive statistics only. But these two things we can do on top of your quantitative data. Okay. When coming to the qualitative data, when the data, it could be categorical type, then we just obtain only frequency count actually. Okay. So even this frequency count, it could be descriptive statistics, but we can calculating the frequency count when the data, it could be qualitative data. So when the data, it could be quantitative, then we can go for applying this kind of standard deviations, quartiles, interquartiles, mean, median, mode. These are all kind of statistics we can apply on top of your quantitative data. Clear?
Yeah.
Okay. Let me make it this one. Mark now. Okay. It could help you guys for understanding. Even if I share this document, you can understand. Okay. Yeah. So, right. Am I run this all things or not? Yeah. Okay. So I have a data something like this, right? So just go on to find that, data of for finding the descriptive statistics, we can apply the describe method. With help of the describe method, it will give you like description for, see, you just see count, mean, median, mean, standard deviation, min, 25 percentile, 50 percentile, 70 percentile, and max. So this this min, it's a Q0 quartile. Okay, quartile 0. This is quartile 1. Okay, this is quartile 2. This is quartile 3. And this is quartile 4. So this is the way the data, the entire data. For example, you have a data having 1 lakh of records or 1 lakh of observations. This 1 lakh of observations we can describe with 5 numbers. We can describe with 5 numbers that we are calling it, say, 5 summary data. 5 summary data. Okay, 5 summary data in the sense, even you have millions of observations are there. That millions of observations we can represent it with the 5 numbers that we are calling it, say, 5 summary data. Okay, this 5 summary data, it could be minimum number from that particular millions of observations, and the max number, so biggest number from that particular millions of observations, and middle number that we can call it as the median, that it could be the 50 percentile of the data. So this is 50 percentile of the data, this is 100 percentile of the data. Okay, so like max number that we can call it as the 100 percentile of the data. So we are taking the minimum value that we can considering the 0 percentile of the data. So 0 percentile data we can represent it with Q0. Q0 means quartile 0. So if you are representing this 5 summary with a quartile, then Q0, and so in between the min and median, there it could be like 50 percentile of the data. So in between the min and median, again we are calculating the exactly middle number that we are calling it, say, 25 percentile of the data. This 25 percentile of the data, generally we can call it as the Q1. Okay, and median value we can call it as the 50 percentile of the data. That 50 percentile of the data, then we can call it as the Q2. So in between the median and max, so you might have some middle number in between the median and max. Okay, so that we can call it as the 70 percentile of the data. That 70 percentile of the data we can represent it with the Q3. Okay, and the max, it could be like 100 percentile of the data. That 100 percentile of the data we can represent it with the Q4. So this is the way, even you have the millions and the trillions of observations, that entire thing we can represent it with 5 elements that we can call it as the 5 summary data. Clear?
Yes.
So when we applying the describe method, okay, here we got the min, 25 percentile, 70 percentile, 50 percentile, 75, and max, right? Okay, when this is index, it's not considerable, but even CC number also it's not considerable because it's a numbers, right? But we can see numbers in the sense it's not numbers. CC number means credit card number. So no one, no two different customers are having the same credit number, right? It is impossible, right? Right or not? Any two people have the same credit card number? No, it's really impossible. Okay, so you just see that amount is one variable. So the minimum, the smallest transaction is $1 or $1, and the max transaction from that particular data set, it could be 1499. That is the maximum transaction the customers has did. Okay, and so middle value, so median value 63 is your middle value. Okay, and 75 percentile. So in between the 73 and 1049, the middle line number is, it's a 117. I think anyone might get some kind of question, sir. 50 percentile in the sense it's a middle number, right? So 1 and 1495. So middle is not the 63. It could be 7. something 7, what it is 2, this is 2. Tell me guys, what is exactly? So for example, let me consider this is 1500. 1500 half is how much? 750, right? So actually this 50% of the data could be 750, right? Yes or no? But why 63?
Yes, yes, yes.
Okay. In between 63 and 749, the exactly middle value, it could be average of those things, right? So that's the biggest issue. So the middle number, it's not always mean. We cannot quantify the middle number is always average. Okay. Yes or no?
Hmm. Okay.
Let me erase this one. Yeah. Let me take it my touchpad. Let me explain. Okay. So guys, phi summary is the very important statistical info thing. So with help of that one, we can describe how your data has been distributed. Okay. Let me talk about some example. So for example, you have the 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 10. Okay. So if we have data, it can be distributed something like that. Then the minimum is, it could be the 1, max is, what is 10, what is middle number?
Right.
So average of these two, right? So because it could be like 10 is even number. When even
Yeah.
number and the middle two things average, we can call it as the median. So 5 plus 6 by 2, it could be 5.5. Okay. For example, if we have the 10 and it could be 11. This situation, it was 11. This is 1. And so middle number is, this is 5, first 5, and this is last 5. And exactly the middle number is 6. Okay. So far it is fine. And what it could be the 25% of the data. So in between the mean and median, so this is mean, sorry, this is min and this is max, right? In between these two, what it could be the middle numbers? 3, 4, 3 plus 4 by 2. How much? It's 3.2, right? And when coming to this one, so this is this two and this two, and so middle average of 8 and 9, it could be 8.5. Okay. So but here the data, it was distributed, some specific format, but in real time the data, it never be this kind of distribution. Okay. So when the data, it was not in this kind of distribution, then how we can do that? Okay. So for example, 1, 1, 2, 2, and 3, 3, 3, and now 4, 4, 5, 6, 8, 9, 10, 11. Okay. So I have a data something like this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 elements are there. This is your count. Okay. This is your count. Fine. And what is the minimum value? Minimum value is, of course, it's a 1. What is the max value? It's 11. So it's a total number of 15 elements, 15, right? Total number of elements is 15, right? So what is the median value? Exactly middle term, not average. Okay, 50% of the data is not the mean, it is middle number. So if it is a 15, then these are the first 7, okay, and last 7, and what is the middle number? 4. Clear? Hello?
Yeah. Yes.
The middle number is 4 because 50% is not the average, it's a median. Median means when we are arranging the data in a sorting order, so the middle number we are calling it the median. Okay, if it is the even number of even number of count, then average of the middle two numbers, that we are calling it the median. Yeah, but if it is the odd number, the count, it could be the odd number. Exactly the middle term we are calling it the median. That means 50 percentile. Now I'm talking about 25 percentile of the data. When coming to the 25 percentile of the data, in between these two, you know what it could be the exactly the middle number. So and this two and this two, right? So these two numbers are middle number 2 comma 3. So 2 comma 3 in the sense 2 plus 3 by 2, how much? 2.5. Okay, and coming to this one, this 2 and 3 and 3, and this is 8. Okay, and so 70 percentile of the data, it could be 8. Okay, so one more time, this is 1, 25 percentile of the number is 2.5, and median number is 4, and 70 percentile is 8, and max is 11. Okay, so here the difference is 1.5, here the difference is 1.5, but here the difference is 4, here the difference is 3, right? So the data is not exactly the same. So here the data, there could be some kind of that means even if you see this one, here the data, it was distributed, okay, normally distributed. So that's the reason we are getting same difference. But when coming to this upper the median, the data, it was not distributed normally. So there could be some kind of variation is there. That's the reason the difference is not same. It could be different. Clear? Even with help of these
Yes.
numbers also, we can easily figure out the data, it was not normally distributed. The data is not normally distributed. Normally distribution in the sense, the differences, it could be approximately same. Okay, any questions?
No, Anjan.
Yeah. So that's what, we got this mean 25 percentile, 50 percentile, 70 percentile max. So automatically the describe function, it could be easily find. So mean in the sense, sum of the all the elements by the total number of elements, that we are calling it's the mean. So you know that what is the formula for the standard deviation? What is the formula for the mean and what is the standard deviation? For example, I have the variable is x, which is having the numbers are 1, 2, 3, 4, and 5, and 6. Okay, so x bar, we can call it as the mean. So total number of elements by sum of the total elements by total number of elements. So 1 plus 2 plus 3 plus 4 plus 5 by total number of elements are 6. So that we are getting the how much? 1 plus 2, 6. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 5, 21. 21 by 6, how much? How much? 21 by 6.
3.5.
3.5. Okay, this is your X bar. Okay. And what is standard deviation? What is the formula for standard deviation? Square root of tell me what is the formula for standard deviation? 1 to n x minus xi minus x bar whole square by n. Is it correct or not?
N minus 1 or n?
So if it is the population data, then it could be n. If it is the sample data, if you are considering the sample data, then it could be n minus 1. Even mean also. So we have a two type of data: sample data, population data. What is mean that the sample and what is mean that population? Population means entire data, all the possibilities or entire data. Okay. Sample means subset of the population. So when we are talking about the sample data, then when your division of with number of elements, then we have to take it the degree of freedom. So total number of observations minus 1. So that is the population. But let me consider this is population data. If it is population data, then the formula it could be this one: square root of summation of which starts with I equal to 1 to n, and every time we are subtracting with the original number at mean, and we can do that square, and then sum of the next element, then total by the n value, then we have to apply the square root. Tell me what is the value for this one? Tell me, guys. X is 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. What is the previous example, guys? One, two, three, 4, 5, 6. Only 6 only we consider, right? Okay, yeah, fine. Yeah, this is X. What is X bar? 3.5. Then what is the standard deviation? And 1 minus 3.5 whole square plus 2 minus 3.5 whole square plus 3 minus 3.5 whole square plus 4 minus 3.5 whole square plus 5 minus 3.5 whole square plus 6 minus 3.5 whole square by n. N means 6. Then they have to apply the square root. So you might be getting some value that we are calling it the standard deviation. Okay. If it is the sample data, then 6 minus 1, it could be 5. So this is the formula for the standard deviation. That standard deviation formula, it automatically applied itself in a describe function. So that's the way when we have a data, numerical data, see everything, it could be numerical. In your data set, whatever the numerical numbers are there, and for all the numerical numbers, which is calculating the count and which is calculating the median, standard deviation, min, max, 25 percentile, 50 percentile, 70 percentile, and max. Is there any confusion regarding about these results?
No, no, Anjan.
Okay. For example, I already told you data, it could be numbers data as well as quantitative data, qualitative data, right? For example, if the data is I want to be finding the, so here we calculating the mean, median, mode, and the variance if you calculating the standard deviation, that means it's a variance only. Quartile, interquartile in the sense Q3 minus Q1. So we calculating that 70 percentile of the data, 25 percentile of the data, right? The difference between the 70 percentile of data and 25 percentile of the data, that we are calling it's the interquartile range, IQR. IQR, interquartile range. Interquartile range means Q3 minus Q1, that we are calling it's the IQR. Okay, you know that quartiles Q0, Q1, Q2, Q3, Q4. This is the way you can representing the number as the 5 elements: Q0, Q1, Q2, Q3, Q4. The difference between the Q3 and Q1, that means 70 percentile of the data, 25 percentile of the data, that we are calling it's the IQR. Okay. And so you already know that the standard deviation, sigma. Sigma means standard deviation. So it's a square of variance. It's a var square. Sigma means square root, right? Square root of variance. Okay, square root of variance, that we are calling it say standard deviation or sigma. So you already know that formulas and everything. Okay, so even if you're not aware of it, and you don't need to remember that all the formulas, but you can try to remember, you can try to by heart 1 or 2 times. Yeah. So that's fine, but I want to you can obtain the frequency count for the categorical variable. So here what the data we have it could be displaying only numerical data, but I want to be find the description for the categorical data also. All attributes exclude include. I want to find the only objects, that means categorical data, frequency, I mean descriptive statistics I want to find out. Then when we go through the descriptive statistics for the object type, then transaction date and merchant category, first name, last name, gender, street, city, right? So here we have count total, we have the 40,000, and there are unique numbers. So out of the 40,000, there are 39,994 unique transaction times are there. Okay, there are out of the 40,000 observations, 30,000 are unique merchants are there. So 14 categories, and 690 people are they are doing the transaction every time, and last name is 1,000. Sorry, last name. So 1,000 last names, unique numbers out of the 40,000. Last names are thousands are the unique. Okay, and gender means female and male. There are two, and the streets. So there is no street is different. Every new state. So the transaction is happen with the different cities and different states, and right. There are 50 states are repeating. Okay, so this is the way job and date of birth and transaction number. Okay, and top. So the latest one, and so if you find that so yes character, so maybe this is the sorting format. When you sort the ascending format, then top it could be this one only. Okay, I mean top in the sense mostly this particular situation, um it could be, it could make, right? So this in this particular in this particular merchant only, there are 62 times this one repeated. Top 62 times, this is the merchant, it has been transaction happen in this particular area. Okay. I mean, shopping. So out of the 14, shopping underscore POS, it was repeated 2941 times. Okay. So Michael, so this Michael name, so 922 times it was repeated. Smith name, it was repeated 893. Most of the transactions are happen by female, it was 20,000 plus. Okay, so this is the single city. Because no cities are same. So that's the reason. So the first occurrence, it could be, that's the reason we got the one. East Michael and Maryland. Okay. So 893 times the state it was repeated. And East Michael, it was repeated 43 times. This is the frequency. Okay. So this is the way you can able to find the descriptive statistics for the categorical, and so descriptive statistics for the numerical. Okay. So even if I go ahead with the exclude, so except object type, so by default it is object type, it is else. Accepting, so exclude object, then we'll be getting the same thing, right? Okay, if I'm include, then we are getting only for categorical type. If you're used exclude, then other than the object, what data we have it, so which is go for calculating the descriptive statistics. Okay, so just remember this single statement. Describe is the function. It could help you for performing the understanding the descriptive statistics. The descriptive statistics will give you central tendency, measure of the central tendency, and measure of the spread. So range in the sense max minus min, that we are calling it the range. So range is nothing but max minus min. You know that variance formula. And if you know the variance formula, then we can calculating the standard deviation. Square root of the variance, that we are calling it's the standard deviation. You know that quartiles, you know that interquartile range. So you know the mean, median, the mode. Mode means if whatever the variable which is mostly repeated, that we are calling it's the mode. Mean means average. Okay. So if you go for see, the mode is a descriptive statistics applicable for the categorical type only. So this is the my mode from the transaction date and time. In the coming to the merchant, so this is the thing, it was repeated mostly, and that it's 62 times out of the 40,000. So this is the your mode. So this is shopping underscore POS is your mode. So that means in this particular area, most of the transactions are happening. This is the category, is most of the transactions are happened. Okay. Any questions?
No, not this.
Hello. Any questions?
No,
I
Anjan.
feel
No,
it. No one have the questions. So let's continue the session on Monday. Thank you. Thank you so much for your time.
Anjan,
And
could you upload all the videos?
yeah, I can upload the audio as well as, I mean, I can upload the video, and as well as I can upload this document. So Patel, what you can do, you can share your mail ID, your consultancy, I mean, your training this team. So I would like to give you access for the class recordings.
Okay, and and where do I send my email?
You can send your training this team. I can receive from them. Okay.
Oh, I see. Okay. And are we having a session this weekend or no?
No, there is no classes on weekend. The sessions, it could be weekdays only.
Okay. Okay. Yep.
Thank
Thank
you.
you.
Bye.
Bye, Anjan.
Bye.